I love when things are two things at once or 12 things at once. Like right now, I feel very much inside this little moment with my voice and this phone. It's going to be heard by Fabio, who's traveling right now, and he's going to listen and then reply. And that's a very minute little moment inside not only a huge universe, multiple universes, but over the arc of time that has sort of no beginning and no end from some people's perspectives. I'm going to attempt to have a conversation with Fabio today that really helps us organize our thoughts around what it is to be a human being grappling with the magnificence of the universe. As a theoretical astrophysicist by education, Fabio is also an exquisite communicator. He works to make sure that we understand all the things that he is grappling with himself, discovering, exploring, providing language for. He writes for Scientific American, for instance. He tries to create words on a page to be read by people who know nothing about the science of the universe, but are completely mesmerized by the potential of even understanding a little, having a little glimpse of the capacity to know what's happening in this big, wide world. And I want to organize this conversation by a couple of themes. And I think I'm going to lean into the themes that Fabio has worked with in TED. He has spoken about the black hole. He's spoken about a space elevator. He's spoken about the paradox. What's that called? Yes, it's called the Boltzmann's cosmological paradox. All these things start with a germ of interest, and then they become theories, and then these theories are worked and pushed and pulled, and they're there to make us understand the possibility of life as we live it, not over there, but how our lives can be stretched into seeing the magnificence of our place in things. Because no matter how big the universe feels, if we can actually place ourselves in it, that's kind of exciting for me. Because then we don't feel so insignificant. Although we really are, and that's also a good feeling. Because how do we measure significance? I think it's all about who we're connected to and how we're impacting the world we live in. That's my take on it. Fabio, welcome to Swell. How do you measure your significance? When you see how big the world, global, galactic world is, how do you measure yourself in the morning? When you wake up and you say, it's my day, I'm living it on an earthly, limited scale, how do you measure your own value? And has that been a driver for your curiosity and the work you do?
Hi, Deborah. Thank you for having this conversation with me. It's my first well, and in general, it's the first conversation of this kind. So let's go with the flow, I guess, and see where this leads. So hi everyone, I'm Fabio Pacucci. I'm a theoretical astrophysicist at the Center for Astrophysics at Harvard and Smithsonian in Cambridge, Massachusetts. And I'm currently flying to a conference of astrophysicists in Colorado named Extreme Black Holes. So yeah, that sounds quite fun and interesting, doesn't it? So, Deborah, you asked me about how do you measure your significance, and this is a very interesting question, actually, and many people ask me, what is your work day like? What does an astrophysicist do? What do you do? You go to the office, you go to the observatory, you only work at night and look at the stars? Well, not really. Sometimes actually it's a normal day at the office. I do calculations, I code, I work on papers and proposals, I teach, I interact with students and collaborators. But sometimes we really do observe the sky with real and giant telescopes, and that's really when it becomes very, very, very interesting. For example, earlier today I was looking at some data that we obtained with the Chandra. So Chandra is a NASA observatory in the X-rays, so very high energy. And this data was about a galaxy billions and billions of light years away. So I think that this is what really makes our work worth. We really put things in perspective in this way. So how lucky am I to be living in such a wonderful planet that enables life, and we are using such gigantic telescopes to look at the light emitted by a galaxy literally at the other side of the universe. And this light was emitted billions and billions of light years ago. Of years ago. So I think that this is what makes our life really, really special, to be able to look at the most profound questions in the universe and try to provide an answer to them.
I'm so happy you're here and you're on your way to the Extreme Black Hole Conference. And I appreciate your answer because I feel from your voice that you are living in wonder. And I want to talk a little bit about wonder and imagination and how that plays a role in problem solving, how that plays a role in creating the roadmap for a study. Because so much of what you posit in the work I've seen in your animations, you do have a comfort zone inside paradox. You do understand that the very essence of life can be stretched and bent and turned inside out, and you're not afraid of that playground, nor do I feel like people like yourself are. I'm going to sneeze. I'm going to pause this. Hold on. See, I had that pause button. I was able to sneeze, and thank you for the blessing. Can you give a sense of where imagination and playfulness plays a role in your studying astrophysics and how you create a comfort zone for yourself to keep on pushing? That's the first question around this topic of wonder and animation and imagination. And the second part is, do you often meet people at these conferences that stimulate you because of their playfulness and imagination around creating the roadmaps for their own study? I'm just fascinated. I know Einstein talks about imagination a lot, so I know that it's so important because if you go down things in a straight line, you're going to miss all the curvy stuff. So around the curvy stuff is the unseen. It's where the black holes live, right? Can you speak to this a little bit? Imagination, wonder, playfulness?
Hi, Fabio. Welcome to Swell. It is such a privilege to listen to you. It personally means a lot to me since when I was in middle school back in India, I wanted to be an astrophysicist. Probably as a result of reading too much Asimov, Carl Sagan, and Stephen Hawking. But anyways, later I discovered computers and coding and my life took another turn. But that sense of wonder that drew me to astrophysics is still there. And so it was so satisfying to hear you talk about what makes your job so amazing. Thank you so much for sharing that. I have one question for you. One of the most incredible things about astrophysics, as you mentioned, is the mind-boggling scale of things. It's beyond mere mortals like us to even comprehend. When someone says billions of years of time frame and billions of light years distance, these are just words after a point, right? But of course, they mean a lot more to someone like yourself. So my question is this: I believe it is very likely that there is life out there, just the sheer numbers. And I fully understand the maths of multiplying a very large quantity of stars out there with an infinitesimally small probability of life evolving. But my bet is that multiplication results in a finite and reasonably large number, but that is still so sparse when spread out across the vastness of the universe that the fundamental constants of physics will simply make it impossible for us to ever come in contact with any other life form. The distances are so vast. The speed of light is such an immutable barrier for us. And even if you do come across some signal or probe from another life in a civilization, it will probably be too late, probably late by a few millions of years for that contact to be useful. And just this thought that there is life out there and we are doomed never to be able to get in touch with it is just a depressing thought. So I'm reaching out to you, a professional astrophysicist, to maybe give me some hope and tell me that I'm thinking about this incorrectly or the numbers fall some other way. And maybe there is good reason to believe that there's a likelihood of life is not only being more abundant in the universe, but possibly a good chance that we might even make contact in the next few hundred or thousands of years. Let me know. Thank you.
Hi, Deborah. Greetings from Colorado. It's quite cold here, and the conference is great. I'm listening to many talks from scientists from all over the US and actually the world. And every single one of these talks is very interesting because it deals with imagination. So what researchers do at the end of the day is to push the boundaries of what is known. And we do this by imagining new stuff, imagining how black holes could shine billions of years or light years away. So everything in research is really originates from imagination. Of course, the typical idea of the scientist is a very gray figure that we are very concentrated, very focused in our books. We always do calculations that nobody understands. And, this is true to some extent. Of course, there is a lot of study, a lot of focusing on doing complicated calculations. But what really matters at the end is the original idea. So, for example, one of the main problems that we have in cosmology right now, so the study of the universe on the largest scales possible, it's how to form the first supermassive black holes that we detect when the universe was very, very young, less than 1 billion years of age. And there is a problem because we already detect at these very early ages supermassive black holes that are huge, are very massive, tens of billions of times the mass of the sun. So how do we form these black holes? The problem is there is not enough time from the Big Bang until we detect these black holes. So many people came up with many different ideas on how to form these supermassive black holes. And, imagination is fundamental. You can have many theories, but we are scientists at the end, so we need to prove our theories from observations, so doing experiments on the universe, and we do experiments by making observations with very powerful telescopes. So to reply to your question, imagination plays really a fundamental role in any research, and in particular in astrophysics, of course. Hello there, thank you for your comment. So the question of the existence of life in the universe is, of course, one of the most important out there. It's very hard to provide a definitive answer to that. So we need to tackle these questions, I think, from a couple of perspectives at least. So the first perspective is how likely is it that life exists outside of planet Earth? From the point of view of numbers, it's likely. There is nothing to do about that. There are so many stars in every single galaxy. Many stars have planets, a planetary system. There are so many galaxies out there. So from the sheer number of planets that are out there, it's likely, not only in my opinion, but in the opinion of most people, I think, that life exists or existed out there. A second perspective is, are we actually going to be able to make physical contact with a possible alien civilization? Well, that's very, very hard. As you were saying, the spatial dimension of the universe is very large. Distances are unimaginably large. With the fastest spacecraft that we have right now, it would take a huge amount of time even to reach the closest star, the nearest star. So from this perspective, making a direct physical contact with an alien civilization is very hard. This is a way to see the Fermi paradox. So where are the aliens if they exist? It's just that it's very hard to make physical contact because the universe is so vast, as you were saying. An alternative point of view is, are we gonna be able to have some proof, some indication that alien life exists or existed in the past? Well, this is a completely different question, and in my opinion, it's quite possible that at some point in the future, and possibly in the near future with the new telescopes that are coming online in these years, it's very possible that we could find some very strong biomarkers. So, the proof that are molecules in the atmospheres of exoplanets, of planets outside the solar system, that are clear indicator that there is life out there. So this is an alternative. So having some indirect proof that there is life out there without necessarily making any physical contact or even electromagnetic contact, so exchanging signals. But in my opinion, getting a proof that life exists out there is not only feasible in principle, but actually quite manageable in the not so distant future, I think. So I hope that this answers your questions.
Fabio, thank you so much for both of these extraordinary answers. There's something so ebullient and possible about your approach to the work you do, and it's really contagious, and I think that's why you are thriving in your industry and teaching and collaborating, because I think, like you said, there needs to be a very expansive perspective when you do this kind of work. And it's so long tail that maybe in your lifetime things won't happen. But you know that in doing the work, you're part of the magic of that. And I'd like to ask you about conferences that, I wouldn't be in your conference, so I have no idea what it must be like to be around people who are so inside this world that is, for us, seems so far away. And you have people working in this world who know the language you know and who speak with the command of what's true and what's here and what's possible tomorrow. What, from a psychological perspective, I can imagine how nourishing it must be to be around people who are at your level. If you were to give your favorite talk, like if you had anything to talk about at these conferences, what would be the talk you'd want to give in 15 years or 20 years that exposes something that you discovered that's not real today? So let's just jump into that imagination. What talk would you want to be giving in 20 years that speaks to something that you think is there, and then you've actually come to realize it is, and you have more to say? Do a little science fiction with me, because it might not be fiction by that point.
Hi, Deborah. What I would like to present at a conference about black holes in, say, 10 to 20 years. That's a very, very interesting question because, scientists like to, wander and wander off with their imagination. So I might go to answer this question with the detection of a habitable planet around a supermassive black hole. That would be something that would literally blow my mind, I think. And at the same time, we are probably very, very far away from detecting anything like this because it's so much above the current capabilities of telescopes and instrumentation in general. So, in supermassive black holes, when they accrete gas from the environment, also emit radiation, to some extent like a star, also, although they emit a much wider range of electromagnetic radiation. Typically stars emit optical light and ultraviolet part, near infrared a little bit, but not much more than that. Supermassive black holes, or black hole in general, emit radio wavelengths up to very hard X-rays or even gamma rays sometimes. So, if there is a planet that orbits at a sufficient distance from the accretion disk of a supermassive black hole, it could be possible that the radiation emitted by this black hole, if it's possibly not accreting too much, could, in principle, sustain life. The detection of such a black hole is very, very far away from current possibilities because, for a matter of angular resolution and flux sensitivities of current telescopes. So they are too small, too far away to be detected. But, in science, really never say never. So it's possible that maybe in 10 years, 20 years with new telescopes, somebody like me will present this detection. And that would be really amazing just to think about like an alien civilization living into such an extraordinary planet. But again, we're just dreaming here, and we will see in the next 1 or 2 decades.
I love how we're just dreaming here, and I love that you discuss imagination as such a main ingredient and dreaming as such an important part of this crazy, roadmap of we have to have desire before anything else, and then everything follows. And I'm in awe of how specifically astrophysicists are always sort of these heroes on some levels, because we lean into you to help us see out of the sort of the banal earthly limitations and all the troubles we're having on this earth, all the sort of the very silly wars and just so many things that don't make sense. It's sometimes so good to look up, and to look up for so many different reasons, for relief and for inspiration. I really hope, I want to first of all thank you for being here, especially here in the conference. You made time for us. I'm so grateful. Everyone's going to be grateful as they bump into this conversation on Swell, because it's in perpetuity here, and I know that it's just such an important conversation with you. And my little hope is that you treat your Swellcast like a little audio diary, and we get to stay inside your head. So please feel free to start your own Swell at any point just by hitting start a new Swell under the talk button, and just start your Swell and keep us inside your world. It's such an honor. And yeah, that's my wish. That's my wish. I asked you yours. That's my wish, to have you be here and be our resident astrophysicist. What an amazing thing that would be. Okay, looking forward. Thank you.